Hi everyone, this video is going to be a part repair job but also a part project. I've got a Denon amplifier that sits below the TV in my living room, which takes the output from the TV and drives a couple of mission speakers that I've got. And I've also modified that Denon amplifier to motorize the volume control on the amplifier so that the button that I use to control the TV also I can control the volume of the Denon amp. I want to do away with that Denon amp and I want to replace it with another amp, this Pioneer amplifier that I bought off eBay. It's quite a good model, I think, from the older generation analog only stuff. So so it doesn't come with a remote control itself, it's totally manual control. So first thing I want to do is repair it. There's a fault with it, and then I want to add in a motorized pot on here with an Arduino inside controlling it and taking the signal from the remote control. So that's what I'm going to do. Going back to the original fault with this amplifier, what the problem is, the amplifier does work, but on the ad it's specified that the tone controls don't work, the treble and the bass. You actually get no output whatsoever unless you put the amplifier in direct mode, which effectively bypasses the tone control section. So without even opening it up, I think the problem is going to be in that circuit, the amplifier circuit that operates with the direct on-off switch there. So I've got the schematic diagram, I've got the amplifier, so let's open it up and see if we can make a repair. Right, that's a cover off of the amplifier. Just a quick run around the internals before we go on. Got the input power coming in here, so you got your power coming on the transformer here. You've got the secondary coming off down onto the power supply section here. There's a couple of large audio grade capacitors there, and you've got the main bridge rectifier there. And wow, that's over at a weird angle. It doesn't look damaged or anything like that, but it's certainly taken a hit at some point. And then you've got the main board itself with the PNP and NPN power transistors on the side of the heatsink there. You can see that there. You basically got a pair, most probably of the left channel and the right channel there. The main board there with these mechanical tails coming off of the input selector switches on the front there that just pull the mechanism back and forward to do the axle switching there, so that's what these are for. We've got this auxiliary board here. Not too sure what that is at the moment. There's a phono selector switch on the front which seems to actuate the mechanical switch on the board, and there's obviously a few components there. And you've also got a PCB mounted on the front panel itself, interfacing all the switches, etc. And obviously that's what these cables are coming back down onto the main board there. So I've got a schematic for the board. It's just on a single sheet here. Obviously it's pretty hard to read, so what I've managed to do is I've blown up the area that I think we're going to be looking at to repair the fault that the amplifier has. And basically it's around this tone assembly board here, or subsection of the main board. I'm not too sure yet, I haven't had a look. So basically you've got the main phono signal, audio signal coming in here. You've got the volume pot, the bass and tone controls there, and you've also got the direct on-off switch that was mentioned in the eBay ad. So what I've done is I've drawn it out a little bit simpler so you can see what's going on here. So basically you've got the signal coming in here and it splits off and comes away along here, and you've got the direct on-off switch. I've shown the switch in the on position, which basically is meant to bypass the bass and treble controls, etc. So you can see that actually happening. It links through onto the main volume pot here, and then you've got your signal coming out here and to go to the power amp. With the direct on-off switch in the off position, you're basically isolating this line here, and you've got the signal coming in through the small input filter network there, through the subsonic controls, through the bass treble controls, and again onto the volume pot. So what the eBay ad was saying is that with the switch in the on position, it's the only time you get an audio output. So obviously what I'm thinking is that the problem must lie in this section here, so that I don't think we're getting anything on this line here that's feeding the volume pot, or probably maybe even the volume pot's broken itself, who knows. But what we'll have to do is get the scope on it and start getting into this here and tracing a test signal, and we'll see what we can get. So back to the amplifier again. Yes, it is a bit crusty, it's quite dusty, in fact it's very dusty really. So I don't plan on cleaning it up just yet. I think we'll get power into it and we'll start locating the tone assembly and see if we can't fix the fault. I've got the amplifier hooked up now. I just wanted to check that the fault that was described in the eBay ad was actually the fault that we're actually looking at here. So I've got it hooked up to a speaker, I've got a signal coming in to the line input on the back from my laptop. So I've got the direct switch on, I've selected line, and we're getting an audio output there. So what should happen is I should be able to switch off the direct switch, and the little LED goes out above it, and I should have audio via the tone and bass controls basically, and you know, we're getting absolutely nothing here. The bass has no effect, I've got no volume at all. If I wind the volume right up, you can hear it buzzing away. Don't know if you can hear that. There's probably some leakage on the board there that we're picking up some audio via some floating input or something like that. That's what I'm thinking of at the moment. You can actually hear the song being played as well as the buzzing. And I turn it right up, but that's to be expected. So yeah, I think the fault's as described there. We're just getting nothing unless we're in direct mode. So I think we'll delve into the electronics now. Okay, I've done a little bit more of an investigation here. So let's recap here on the diagram that I made. Basically, you've got the signal coming in, it splits, it goes up here via some onboard connectors and jumpers onto the direct on-off switch. Basically, for the direct on functions, it's enabled to bypass the bass and treble controls to then feed the volume pot. And that goes via pins 5 on this CN4 jumper, interboard jumper connector. You've also got the same signal coming in through a little RC network here, little filter, off to the same jumper connector, but on pin 1, and then that obviously feeds the bass and treble controls, etc. So that when the direct on-off switch is in the off position, that signals are fed up through here, and you also got direct on here coming onto the volume pot and the additional wiper. Now, so what I was expecting to see on the oscilloscope was that I was be getting both signals present there. They probably look almost identical on the scope because you've only got a small RC network there. So basically I was looking to see that they were both present there. So before I started troubleshooting any further, what I thought I would do is I took a 10k resistor and I've jumped that between pins 1 and pins 5. So therefore I would be getting a signal going to here as well as a signal on here. And when I do that, the whole amplifier is working good, working correctly. So I've got it powered up now. I'll just power it up now. I'll wait for it to kick in. So that's an MP3 I've got playing into the input, and that's the direct switch in the on position. And if I move the bass and treble controls in the front, you can just see me just out of shot there. No effect. So that's exactly what the direct should be doing. And also the balance control should be doing nothing as well. It's bypassed as well. And yep, that's totally dead because I've only got one speaker hooked up. Therefore, if the balance control was working, it would work on one side only and be totally quiet the other side. So let me just disengage the direct switch and as you can hear, we're still getting audio output, and you probably can't hear it too well, but the bass and treble controls are indeed working. And if I move the balance control from one side, it's totally dead. Right down the other side, it's working. So that's proven that this circuit here is working okay. Your bass and treble pots, etc. Well, as you can hear there, it's all up and running now. And hopefully, if you can see, there's no longer a test resistor across pins 1 and 5. Is this a schoolboy error, what I've found? Well, I don't really know. I think maybe I was just caught up in the eBay ad that said the amplifier didn't work in direct mode. And from that you think, well, you know, there is a genuine fault going on here. But in actual fact, there's not. So looking at the schematic diagram again, there you've got CN4, which is that connector with the pins 1 and pins 5, and as I was saying, one of them was dead, one of them's okay. And if you look back along through here, and you've got the RC network was talking about there, then you've got these two, it looked like just traces to me, but in actual fact they're outside the boundary of the actual PCB. And basically you've got labelled there adapter in and adapter out. So basically you've got the signal coming in here from the main input, and it splits. One of them goes round that jumper there straight into CN4. The other one goes through this jumper here and then through the RC network. Now bear in mind it's the RC network that I was saying was dead. And in actual fact, these are phono connectors on the back of the amplifier, and they're marked adapter in. You've got a pair for left and right, and you've got another pair adapter out. So looks like it's for some external preamplifier or something like that, or a graph equalizer that you can put in series with the signal there. And if you are not using it, then since there's no way to bypass or switch out this connector, you've actually physically got to put a jumper in from the adapter out to the adapter in, and that completes the circuit. So there, looking at the back of the amplifier, I've now just on one side only, on the right hand side only, I've put a jumper in from adapter out straight into adapter in. And obviously Pioneer would have supplied some jumper cables, a pair of cables that the user would just jumper them out if they're not being used. But obviously the seller of this amplifier obviously didn't realise that in the same way that I didn't realise it, and hence fitting that jumper, and it's all working great. So now that I've got the amplifier quote repaired unquote, I think we can now move on to modifying it. What I was looking to do was replace this manual volume control here with a motorized pot in much the same way as I did my Denon amp. So looking at the back of the pot here, it's not going to be so easy in this amplifier board here, is because there's actually a circuit board directly over the back of the pot. It was relatively easy in the last one I did, because basically the pot was wired down, with some physical wiring down onto the main PCB, so it was basically free to do what I want. So basically what you can see here is there's the pins for the pot, and that's just the fixings that are obviously just down to earth there for for mounting the pot. So I've got a couple of options here, but I think what I'm going to do is, might sound a bit drastic, but once I get the board out and have a look, probably what I'm going to have to do is cut the corner off of this board here, therefore cutting the pot right off the board, and it'll allow me to put in my motorized pot and then wire it back down onto the PCB there. And there is a couple of traces that come round the end of the board and loop away around. It's obviously for something else, so I'll have to reinstate those, probably with jumpers, just direct jumper them. But probably luckily for me, the volume control's right on the corner of the board. It's not mounted somewhere in the middle or anything like that, which would be done a lot tougher probably. So it looks like I may get away with just cutting the corner off the board there in order to get the motorised pot in. Okay, this is the corner off the circuit board which I've managed to cut off, and as you can see in place now is the new potentiometer, the volume control, minus the motor control, which I've not done yet. But the first step first is to get the pot working in place of the old one, which I've managed to do. If I can just turn the volume up here. As you can hear, it's working. There is one thing I've had to do, however. Let's along here look at the schematic diagram, or the block diagram first. As you can see, this is the treble and bass controls here, and then you've got the direct on-off switch here. The new pot that I've got, the new volume control that I've got, doesn't have this fourth connection here. This is like an extra wiper, although it's in a fixed position at about mid-range of the 100k range of the pot, so it's, you know, it's a bit mid-range there, and it's only this side here, the output side here, that's basically wiping back and forwards as you you know, adjust the volume up and down. So without that fourth connection there, you know, I wouldn't be able to get the onboard treble and bass controls working. So what I have done is I've actually gone and cut this line here and directed it up onto the top end of the potentiometer here, and I've actually disconnected this wire here. So in effect, I've got the bass and treble preamp output routing up into the top of the pot here. So therefore I get the volume control, you know, volume controlled output there. And it does mean, however, the direct on-off switch no longer works. It's basically in the off position all the time effectively. One other thing to note, you will remember that there was actually two traces that went right along the edge of the board here, round the corner and down. They really had nothing to do with the volume control, so I've had to reroute them. So I've just used some wire wrapping wires. You can see the two wires there. I've still got to seal them down onto the board, but you can see them running from the two positions there. So that's all in place, and it seems to be working fine. So the next thing to do is actually get the motor control board working. So I have actually started assembling the board itself on VeroBoard here. See, I've got the Arduino Nano in place, I've got my 5V regulator there, and the input capacitor, fuse, etc. Still got a ways to go to build that up. Basically, I can't just stick in a 7805 or drive an unregulated DC onto the Arduino Nano. Reason being, the onboard DC voltages on the Pioneer board itself are way up 60 volts or approaching 60 volts. So that's 60 volts DC that I'll actually be tapping into to power this board. And of course your normal 7805 regulator, etc., your Arduino Nano can't handle that higher voltage. So I quite like the use of the LM2575, I think the number is, switching regulator. It can go up to 60 volts, and it's quite a good, nice, stable, easy to use 5V regulator. So I'll be using that like I did in the last the amplifier that I modded, much along the same way as I've done this one. So what that's going to do, that's probably going to mount in here somewhere, or on the back there in the inside of the case. And I'll wire it down onto the main board, and of course hook up the motor on the back of the volume control direct to this board here. So the next step is to complete the motor control board here. Obviously got all the wiring to do in the back, and a few more components to assemble onto it, but I can just let you have a look at the schematic at the moment. This is what the circuit will look like. You've got the LM2575 there, which has got a range, like I said, about 760 volts, so that should handle the input DC fine. And you can see you've got the 5V output there. You've got the Arduino Nano down here, and I've got the IR signal coming in here. This is it actually here. This is a hoppage IR receiver, and it's basically just got a a 2.5mm jack. So what I'm going to do is I'm going to put a 2.5mm socket on the back of the Pioneer amplifier, and this will just plug into it, and then obviously the internal wiring will come onto this board here, and that's it coming straight into a D7 on the Arduino Nano. It's a TTL level pulse, so it's perfect for coming into the Arduino Nano. Just a quick look, this is the actual remote control that I use. Like I said, I use Media Portal for watching TV, so this is actually a Media Portal compatible remote control, and I use this volume control here controls the volume output on the TV, which drives the amplifier here. But I'm going to use this channel up and down here. I'm going to reroute that, to redirect that in the software, and it'll actually be driving the motor on the new pot that I've added to the Pioneer. So basically I'll have two volume controls here, one for the TV and one for the main amplifier. So back to the schematic again, you can see that I've hooked up, I'm going to have an H-bridge set up here for driving the motor. That's the motor there. Two N-type and two P-type FETs. There are ZVN 3306A and ZVP 2106A. I'm quite used to using them, I quite like them, they're easy to use. And basically with 4 of them, 4 Schottky diodes and 4 resistors, basically it'll directly interface to the Arduino Nano, and all the control will be done in the software obviously. One thing I will have though is there's a 15 ohm 2 watt resistor there, just to limit the current to the FETs. What that's for is just in case something goes wrong, perhaps in the Arduino Nano, a fault or something like that, and it tries to switch on both of these FETs at the same time, we'd be effectively shorting out the 5 volt rail. So I've just got a 15 ohm 2 watt resistor there just to limit the current there. And the other thing I've got is a small buzzer which I'm going to mount on this on the board as well, so that when you press the volume control on the remote control, I'll just give a short beep on the buzzer as well. So it's a pretty simple circuit. The software is even simpler. It's just a few lines of code and that's it. This is the original volume control. It's a 100k dual log pot, and as you can see here, you've actually got 8 pins in total. This bank of 3 here and this 3 here are the main potentiometer. It's this 2 in the end here. You can actually you can almost see it there. You've got a track leading off of it round, and it just actually taps midway around the 100k carbon track that makes up the actual the main part of the potentiometer there. And you can actually just about see it if you look in there. You can see the track coming round. You can just see it sort of tapping midway or almost midway around the 100k track there. So when you operate the pot, it's not actually wiping at all. It's just a permanent tap onto the track. Of course, like I said, my motorized pot, my new one, doesn't have this 4th pin. This is the power supply section of the amplifier. I thought I'd take a look and see where I'm going to pick up the power for the motor control board. You've got the input transformer here, mains transformer here, bridge rectifier, and there's that 2 large electrolytic capacitors there, which looks like I've got about 44 volts, plus or minus 44 volts there, and that's actually feeding into a small discrete regulator circuit here, which is given about plus or minus 16 or 17 volts or so, but only, by the looks of it, according to this, at 25 milliamps. So I'm actually going to pick the power up for the board at the 44 volt stage here. I don't really want to take anything from any existing regulator circuit inside the amplifier, because bearing in mind I'm controlling an actual DC motor, and not just for the current that will be drawn from the power supply. It could be up to a couple of hundred milliamps or so. It's the noise that may be induced back into the circuit from the motor. I wouldn't anticipate that really, but just to be better safe than sorry, I think if I pick up the power for the actual motor control board at the unregulated stage here, then there's much less chance of actually putting any interference or injecting any noise into the amplifier. So I'm going to pick up the 44 volts here, I think, and that'll be fine for the LM2575 that I've chosen as the 5 volt regulator. It should work just fine. Okay, so let's see if I can find out where to pick up this plus 44 volts power supply. Okay, I'm using the case as ground there, as is shown on the schematic diagram, and looking down by the capacitors here, I've got a few terminals, wire posts. I'll just probe onto here and see what I can pick up. So there's the minus 45 volts, so thinking it's possibly this one here. Yep, there's the plus 45 volts there, so that's on a post down beside the electrolytic capacitors. So I think that's where I'll pick up the power for the board. So one of them will be ground, so I'll switch off the power supply and check the continuity down to the chassis, and that'll be my 0 volts pickup. So with the power off now, looking at the posts that I'm picking up the power from, there's actually 3 posts down there. You've got the minus 45, the plus 45, and there's a third one there. And if I check the continuity to chassis, it's 0 ohms, so that's my 0 volts pickup. And actually, if you look closely, there's actually a wire coming off that post up onto the power supply. That's centre tapped there, so that's your normal method for picking up your dual rail power supply. Okay, amplifier aside for a moment now, it's time to get back working on the control board for the motor. You can see here I've already part assembled it, and I've got this collection of parts here still to put on. I've got the buzzer, the Schottky diodes, the FETs, and the large 2 watt resistor there, the 15 ohm resistor. So I've got that to put on the board, so I'll get working on that now. Okay, that's the control board fully assembled, and it's fully wired up as well. You can see you've got the FETs there, P-type and N-type. I've got the 15 ohm 2 watt resistor there feeding the supply to the FETs. I've got the Arduino Nano, I've got the LM2575 and its decoupling capacitors and output, the Schottky diode and the output, the incoming fuse and electrolytic capacitor on the input as well. I've got the buzzer, and I've got a FET drive in the buzzer there, and there's a coil on the back of the heatsink there for the regulator, and the input terminals and the power terminals. I've beeped it out, there's no shorts, everything seems okay. I've double checked the power circuit, as you can see I've put heavier gauge wire, single strand wire, and all the power related stuff, the incoming power and also the drive to the motor there from the FETs, that's all heavier gauge, and then all the low current stuff's just using normal wire wrapping wire there. So it's a nice size board, it's all ready to be tested. So I've got it hooked up to my bench power supply. Like I said, I've already beeped it out, so I know there's no shorts, so it's just a case of putting in an incoming power there. I'm just going to start off at 15 volts, and I'm also going to disconnect the Arduino Nano. I don't want to power it up until I know the 5 volts is okay. Just to have a quick look at the schematic here, you will notice that even though I unplug the Arduino Nano, I won't have floating gates on the FETs. I've actually got pull downs and pull ups where necessary to keep the H-bridge in a safe condition, even though I've got no Arduino Nano hooked up. So let's apply the DC power. The power supply is out of shot, you can't see it. So let's see. So I've got just over 15 volts there, and there's 0 amps showing on the power supply, so I know there's no dead short or anything like that. So let's double check the incoming power there, just 15.22 there, and I'll go straight to the DC, the output from the regulator, which I think feeds this resistor here, so that's 5.06, so that's looking good. Arduino should be on this pin here, so 5 volts and 0 volts is connected. So we're ready to plug in the Arduino Nano. So I'll turn off the power at the power supply. It's the buzzer making a little noise there as it powers down. And that's the Nano plugged in. And we've got the orientation is correct, so we're ready to power up with the Arduino Nano in place. So eyes on the power supply again. That sounds good. There's an Arduino Nano powered up there, and I've got one of the routines on power up is just to send a little beep to the buzzer there, so that seemed to work okay. So I'll just double check the incoming power again. 15.2 and power to the Arduino Nano. 5 volts, spot on. Okay, I've got the IR LED hooked in now, plus 5 volts signal in common here. What I should get if I put my meter across the H-bridge output here, these two terminals here, I should get plus 5 volts or minus 5 volts, depending on whether I hit the up or down button on the remote control here. So let's try that now and see what happens. So 0 volts in a normal off condition, that's good, that means the motor's not going to do anything. So let's hit the up button. Yeah, it's a momentary output. I've got it won't stay on continuously, that's just how I've written the software. So you can see I'm sort of getting plus 5 volts there, and if I go in the other direction you can see it's flashing up more or less minus 5 volts there. Of course the true way to test it is to put a scope on it to see what the outputs are actually doing, but I'm happy enough that that's going to be okay. Everything seems to be fine, so I think the next test is to build it into the amplifier and hook it up with the actual motorized volume control. Okay, that's the board fitted now. As you can see, I've screwed it to the back of the case there on some L brackets that I found, and it's all wired up as well. This is a plus 45 volts there coming from the wiring posts down by the capacitors there. I put a bit of heat shrink sleeving over it just to protect it a little bit. This is the IR LED, IR sensor signal there coming from the back panel there. I've got a 2.5mm socket there, and it's connected in the back there. And I've got the motor drive signal there from the H-bridge circuit, and that's it running up onto the back of the motor. So I think it's time to power up now, check some voltages, and then see if it's actually working. Okay, first things first, I've lifted the fuse just so I can check the polarity etc. of the wiring coming up onto the board there. Check my wiring there, I've got a little diagram here, positive on the left and negative on the right, so that's the right way round there. So let's power up and then I can check the incoming. Okay, we've got power there now, and onto the terminals there, and I've got positive 45 volts, correct polarity. Now let's power off and wait for it to go down. There we go. That's good enough. So I'll put down the fuse and power up again, and we should see LEDs on the Arduino Nano if it's powering up correctly. And a power up beep as well. So now we'll check the 5 volts to the Nano. Yep, 5.06 volts, that's working fine. And on load I'm still getting my plus 45 volts, so that's correct. And the motor drive 0 volts, that's good, so that's not turning in at the moment. So I've already got the IR LED hooked up, so now it's time to test the actual motor and see if it actually works. Okay, I've put a bit of masking tape on the 0 position on the knob there, so let's try it out. And I'll go the other direction. I'm actually holding the button down on the remote. What I've got the software doing, it moves the motor by a set amount, then I've got a delay, a pause, and then it goes again, just to keep the speed down on the actual remote control. So that's why we're getting a beep 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 rather than a continuous tone. I'll put it at full volume now. The motor's designed with it's got an internal clutch, so that if you do go fully in one direction, and as you can see there, actually the knob stopped turning. The motor will actually keep on turning because there is an internal clutch, so you're not going to burn out the motor or anything like that. They're designed to do that. So I'll go down the way again. The software's set up pretty simple. It's just operating on this redundant channel up and down button on the remote. But I suppose what I could do, I could probably tie in some of the other buttons, maybe the number buttons, because I never use them, to set the knob to preset positions like halfway or, you know, some other positions there. Possibly could even make it remember positions, but I don't really want to get too complicated at the moment. I just want simple operation of the volume control. And everything's cool. There's no temperature rise or on the 2-watt resistor or on the regulator at all. Everything's stone cold, so that's good. I've fitted a 2 amp fuse. I could probably go down to 1 amp. The motor's designed to draw about 100 milliamps in normal operation and up to 150 when it reaches the end of its travel and it's getting some additional load via the slip and clutch. So you're talking about 150 milliamps, I don't know, a few milliamps for the Arduino Nano itself and the buzzer, etc. So you're not looking at much, you know, so probably a 1 amp fuse will do. I don't think we're going much above 300 or 400 milliamps. So I think the next thing to do is to put the case on, the lid on the case, and then try it indoors. And finally, here's the amplifier mounted below the TV. It's all hooked up to my media portal setup here, so I'll just increase the volume.
Looking for the summer. The eyes take on a southern gaze.
Working good. Job done.